it's time to take a look at the pedal board now and figure out how we're going to connect this to the rest of the organ. We will be using a matrix keyboard interface, the same as the ones we used on the keyboard, but because there are only 32 pedals instead of 64 or 61 keys like you'd have on the keyboard, we will only need 4 of the columns of the matrix rather than the full 8. So this is a matrix keyboard effectively, although quite a big one. So if we take a little bit of a closer look at this now, if I just zoom in on the circuit boards on the back of it, we can see there that we've got 5 switches, and above those switches we've got 5 diodes, and just on the far right hand side here there's a multi-way connector, and that multi-way connector has 12 pins, which would suggest to us that we have an 8x4 matrix. So there'll be 8 rows and there'll be 4 columns, giving us 32 notes. We've got the diodes here already, and we've got these sort of push switch arrangements, and the way they work is when you operate a pedal, it squashes it down with this rubber ring arrangement that just makes it a bit kinder on the top of the actual switch. So what I'm going to do, I think, is to get the original connector from that board, which has about 8 inches of wire connected to it already, multi-way cable, and that originally went to the 12 pin or 15 pin D type socket on the back of the metal cover. Well, we're not going to use that because we don't want a long connection between the pedals and our interface board. So what I'm going to do, if I zoom out a little bit again now, I'll just show you what the plan is here. So we have the normal keyboard interface like we've used on the other keyboards, and what I'm going to do, we've got our 8 columns and 8 rows here, so we're just going to use all 8 rows and 4 of the columns, and I'm going to use the original bit of cable which I've got over here. So that will plug into this socket here, and then these wires will connect to our board here, and then I'm going to mount this board on the side here like this. We've got an issue with how we're going to connect our RJ45 to this, because there is a big metal cover that covers all of these boards and everything else, and this is going to be inside it. So I did wonder about putting it that way up so that you can access the sockets there, but obviously it's much too tall because the cover's here, so that won't work. So if we mount it horizontally, somehow we've got to get an RJ45 cable in and connect to there, which is not going to be easy. So what I've done is I have acquired from Amazon one of these, and basically it's just a panel mount RJ45 pass-through. So I can mount the board wherever I want, have a short cable coming from that plugs into the back of this socket, and then I can mount this socket actually on the metal cover, and then it's easy just to plug an RJ45 cable into that, and the other end plugs into the organ. So that's the plan. I'll go through in a minute and just check which wires go to which of these switches, which parts of the matrix, and I'll show you that. But once we've done that, it's just a matter of fix the board in here. I'll make a little bracket or something and get the thing wired up. It's only 12 wires, so it shouldn't take too long, and hopefully everything will be good from there. Okay, so as we said, I've got this bit of wire that was originally connected to here. This end went to the D-type socket, so I'm going to plug this in to this circuit board like so, and then we're going to work our way along it and see what the different wires do. So starting at one end with this, quite often people used to wire these things, anything sequentially, using the same colours as the resistor colour code. So there's probably a good chance that if we take the black wire, which is 0 in the resistor colour code, and we connect that to our meter, to one side of it, that if we go to the first diode, that will be, and it is, so stand the meter up. I don't know if that's going to show up on the video actually. Is it even in shot there? Just about. It's a bit difficult to get everything in shot, so probably better off with a longer view like this, and you can hear the noise the meter makes hopefully. But certainly that black wire, that connects to diode number 1. So if they're using that system, the brown wire, being as that is the next one in the colour code, so black is 0, brown is 1, should connect to the next diode, which it does. The next one will be red, so that will connect to the third diode, which it does. And the next one will be orange, wherever that's gone. That's right, that's that one that's broken off, so we can't really do that. We'll do that one in a minute. The next one will be yellow. Orange is 3, yellow is 4. So let's try the yellow one. So it should be 1, 2, 3, 4. So it looks like the orange one's not in use. So we've got black, brown, red and yellow. And then green should be 5. Which it is. 1, 2, 3, 4, 5. Blue will be 6. Which it is. Violet should be 7. 1, 2, 3, 4, 5, 6, 7. Which it isn't. Okay, they're using that. Maybe that's a common, I don't know. Grey would be 8. So it's probably going to be 7. 1, 2, 3, 4, 5, 6, 7. Yeah, grey is 7. White is the next one, so that's probably 8. 5, 6, 7, 8. Yeah, and then of course we'll be back to black for number 9, because being a matrix it repeats. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is back to black again. So that takes care of those wires. Our columns therefore are going to be the ones that are left over, which are pink, violet, blue. We need 4 of them. I'm guessing orange would have been the other one. We'll figure that out later. So let's see which ones go to where. So now it becomes important which way round we've got our meter leads, because the diodes obviously only conduct one way. They are pointing towards, or the the cathodes of the diodes are connected to, if you want, via the switches, the common lines. So we need the negative lead of the meter to go to the common line, and the positive lead needs to go to the diode. So let's figure out what these common lines are. So let's just pick one at random for a minute. So let's try with the pink one. So if we put our positive lead on that diode there and operate the switch, that works. So therefore the pink wire is the first column, so that's going to be 1 to 8. Let's try the same with the violet. So 5, 6, 7, 8. So this should be the next one, which it is. So violet's the second column, and the turquoisey one. So what we got? Hang on. 1, 2, 3, 4, 5, 6, 7, 8. So that's the first column. 1, 2, 3, 4, 5, 6, 7, 8. That's the second column. So this should be the first one of the third column, which it is. And then the fourth column will be, I hope, the orange wire that isn't here. Let's just have a look where that went. The orange wire is the last one, that's the one at the very bottom there. So let's connect our meter directly to the actual pin there, and we can do the same now for the last column. So let's just pick one at random. So there we are, that works. So the orange wire that isn't was for the last column, so maybe the last column didn't work. I don't know why that's not there. Anyway, that's what we'll do. So now we know what everything is. We don't really even need to write it down, because we've got our rows here 1 through 8, and we know that they are these in the resistor colour code order, so that's easy enough to do. And we know that these last 3, that the pink was column 1, the purple was column 2, the blue is column 3, and we'll just have to solder a wire on the back or something for column 4 and get this board mounted. So I'll go ahead and solder these wires on, get the board mounted, and we'll come back and I'll show you that once I've done it. Okay, I've secured the board to the pedal board now, so this is our matrix keyboard interface, and I've made a little bracket out of some aluminium angle and just bolted this board to the bracket with some spacers and bolted the bracket to the side of the pedal board. And there's a third fixing at the back here. I've just screwed a piece of wood down to the pedal board, and again there's a screw through the circuit board with a spacer underneath. So that makes for a nice strong fixing, so that's all good. I've connected up our old piece of cable, which is plugged into this original circuit board, and I've run an extra cable or wire. This white wire runs from that socket on the, or sorry, from that pin of the socket at the back to replace the orange wire that didn't work for whatever reason or wasn't there. And that's all working fine. So I've got this plugged into our control unit right now, or the control board, just so that we can see that it's all working okay. So if you take a look at the computer and I press the pedals, you can see that we get note on off as we work our way up the pedal board, which is obviously exactly what we need to happen. So that works obviously all the way up the board. So what I'm going to do now is to put the metal cover on. I've made the hole in it and fitted the RJ45 pass-through socket so that that all looks nice and neat. Obviously we can't put that on there whilst we're testing it because we can't see what we're doing, but I think we're happy that that works now. So I shall put the cover on and you'll be able to see what it looks like in its final state. Okay, so we've got the cover mounted now onto the pedal board, and we're plugged into our new Ethernet socket on the back there, so that's nice and neat. And again, if you look at the computer screen, obviously as we press the pedals, then we get the note on offs, which is exactly what we need to do. So that's pretty much it really for the pedal board now. So that's the end of this video. That was a nice simple short one. And the next thing we'll be looking at is putting all of the control board and power supply and all of that into the actual organ itself, and installing the hardware for our sound generation system, which is going to be a Raspberry Pi. So that's the next video. So thanks very much for watching so far.